Hello everyone, welcome to another Fellow Engineers YouTube video, where today we will be discussing mensuration of areas under the analytic geometry and trigonometry category. So a quick overview on what today will involve: the dimensions, perimeter, area, and other geometric properties constitute the mensuration of a geometric shape. Such shapes we will be reviewing today will be the parabolic segments, ellipses, circular segments, circular sectors, parallelograms, and regular polygons. Okay, so for ellipses, we're going to calculate the area to be pi times a times b, and the approximate perimeter length to be 2 times pi times the square root of a squared plus b squared, all divided by 2. So the figure shown here is a scenario of an ellipse. So A and B are the semi-major and semi-minor axes respective to the origin or the center of the ellipse, given the coordinates h, k. So let's start with an example problem. So an ellipse has a semi-major axis with length A being 12 and a semi-minor axis with length B being 3. What is the approximate length of the perimeter of the ellipse? So we're using the approximate perimeter of the equation, giving us the formula 2 times pi times the square root of a squared plus b squared divided by 2. And when you plug in those values and simplify that out through the calculator, you'll get an answer to be roughly 55. A circular segment is a region bounded by a circular arc and a chord. As shown in the shaded portion in the schematic, the arc and chord are both limited by a central angle, which is phi. To use the first equation to find the area of a circular segment when its central angle phi and the radius of the circle r are known, in the first equation, the central angle must be in radians. For the second equation, to find the central angle when a radius of the circle and either the height of the circular segment, d, or the length of the arc, s, are known. So let's get into an example problem. So two 20-meter diameter circles are placed so that the circumference of each just touch the center of the other. And what is most nearly the area of the shaded region? So we're going to be using the circular segment equations to determine the shaded area. The top right schematic kind of represents what we are given in the problem statement. So we're given the area, or not given, but we know what the area and the phi or angle equations are, and we want to end up with the area as our answer. So we're going to need to know what the radius is, we need to know what phi is, and keep in mind that it's going to be in radians. So let's start by using the phi equation and use the 2 times arc cosine times r minus d all over r. And by substituting those values in, we'll get an angle of 120 degrees. And when we convert that to radians, we'll get a radian of 2.094. And when we plug that value into the area formula, and we know what our radius is, with that being 10, we're able to calculate the area of just one of the circular segments to be 61.4. And when we get the area, we don't want to stop there, because that's actually the area of the circular segment for just a half of the shaded portion. So we're going to have to multiply that answer by 2 in order to get the entire shaded region to be our answer of 100. A circular sector is a portion of a circle bounded by 2 radii and an arc, as shown in the schematic here. Between the 2 radii is a central angle, phi. To use the first equation to find the area of a circular sector when its radius r and either its central angle and or the length of its arc s are known. The central angle must be in radians, as like we just discussed in the central circular segment. In the second equation, we're going to find the central angle in radians when the arc length and radius are both known. So for parallelograms, we have several equations that we're going to be introducing. So for starters, the schematic represents a good visual of what a parallelogram is, and there are certain measurements and variables for each of the lengths and positions. For starters, we're going to get the perimeter being 2 times a plus b, the distance for point 1, or length 1, as well as the distance for point 2. And then we're also going to use d1 squared plus d2 squared equals 2a squared plus b squared. It relates to the sides of the diagonals. And then lastly, the area to be the a times h, or ab sine phi. And lastly, to finish up this discussion on this topic, we're going to do regular polygons. So regular polygons, the schematic shown here, where we have two angles actually, which is phi and theta, phi being the angle from 2 points and from the center, and then theta being the measurement for one of the angles outside. So we also have a radius, and we also have the length of the sides, and n will be the number of sides. So for phi, we're going to determine phi by doing 2 pi divided by the number of sides. For phi, we're going to do pi n minus 2 over n, and that could also just be pi times 1 minus n over 2. For the perimeter, we're going to do the number of sides times the length of sides, and then we're also able to calculate the length of each side, as well as the area of this rectangular polygon. To finish it up, let's go over a quick example problem for these regular polygons, and it has 6 sides, each with a length of 25 centimeters, and we're asked to find what is the length of the apothem r. So we know what the r variable will be. So let's start with determining what we are given. We're given the n value to be 6 and the s value to be 25, and we're asked to find r. So for the solution, we're going to use the equation that initially solves for the number of sides, or the length of sides, and we're going to rearrange that in terms of r, as shown down below. So we need to know what phi is, and phi is 2 pi over n, which we will be able to get, and that will be in terms of radians. And then we'll convert that to degrees for this scenario. And when we plug those variables in, we'll be getting a apothem distance r to be 22 centimeters. Alright, that concludes my YouTube video today on mensuration of areas. I hope you guys enjoyed this video and took something away before you guys started. If you enjoyed this video, please make sure to like, comment, and subscribe, and I hope to see you in a future video. See ya.